In this video, we will comprehensively explain what Polygon is and how it functions. We will also delve into the specific tokenomics of the Matic coin, offering insights into its unique features and benefits. Let's get into it, shall we? In 2017, a group of 3 Indian developers recognized the challenges faced by Ethereum and set out to find solutions, resulting in the creation of Matic. This project has now been rebranded and is known as the Polygon network. However, it's important to note that the associated cryptocurrency is still called Matic coin. Polygon operates as a Layer 2 scaling platform, empowering Ethereum-based applications to address the challenges mentioned earlier while leveraging the security features of the Ethereum network. The primary focus of Polygon is to enhance the adoption of decentralized finance, DeFi tools and applications by establishing seamless connectivity between blockchains. Currently, the network hosts over 3,000 decentralized applications, with more than 80 major projects having migrated from the Ethereum main chain to Polygon. Given the similarities between Polygon and Ethereum, many developers who create valuable tools opt to transfer them from Ethereum to other Ethereum virtual machine, EVM, blockchains like Polygon. This strategic move allows developers to broaden their user base and drive greater adoption of their applications. For those wondering about EVM, it represents the code executed by computers worldwide to facilitate the implementation of smart contracts within the blockchain. Polygon is not the only network that utilizes the Ethereum virtual machine, EVM. The Binance Smart Chain, Phantom, and several other prominent networks also employ the main Ethereum code. Due to their shared code base, developers can seamlessly transfer their projects to these networks with minimal modifications. When we mention Polygon, most people associate it with the Polygon Proof of Stake, POS chain, which functions as a sidechain to Ethereum and utilizes a POS consensus mechanism. While this sidechain introduces some modifications, the key aspect is its enhanced speed and scalability, enabling it to process significantly more transactions per second. Consequently, it becomes more cost-effective for end users. However, it's essential to understand that the Polygon network extends beyond the sidechain concept. One of the fundamental goals of Polygon is to provide developers with user-friendly and versatile tools. This empowers them to accelerate Ethereum's evolution into a multi-chain platform. In simpler terms, Polygon encompasses a series of interconnected blockchains that assist in scaling Ethereum. By achieving this objective, developers gain the ability to create various scaling solutions that can be utilized with Ethereum. These solutions include entirely separate chains like ZK rollups, optimistic rollups, or any other desired sidechains. Polygon offers unique and creative solutions to bundle data and save space on the main Ethereum chain. While the Polygon Proof of Stake, POS chain, is one method of scaling Ethereum, the network has broader plans to develop various scaling solutions. Initially, Polygon may seem simple, but its internals reveals many functionalities beyond the regular user's perception. We can summarize Polygon in one sentence for users like you and me. It's essentially Ethereum, but with incredibly low gas fees. Transferring Ethereum from one account to another incurs a fee of around $20. However, on the Polygon network, the cost is less than a penny. This affordability empowers users to explore new applications and test functionalities without fearing substantial costs, such as losing $150 in a token swap. So, how does Polygon operate? Now, let's delve deeper into how Polygon operates. Polygon is primarily driven by a Layer 2 scaling solution and a proof-of-stake protocol. It is a committed chain, functioning as a transaction network closely connected to the main Ethereum chain. In simple terms, the commit chain operates alongside Ethereum, complementing its functionalities. To better understand the concept of a committed chain, imagine it as a mechanism that groups clusters of transactions and processes them collectively before sending the resulting data back to the main Ethereum chain. This can be likened to taking periodic snapshots of the transactions instead of sending the entire video stream. By doing so, the Ethereum chain can still comprehend the activities occurring on Polygon without processing extensive data. This efficiency allows the Polygon network to achieve a remarkable processing capacity of up to 65,000 transactions per second. Some experts even predict a future scenario where developers host thousands of chains that work with Ethereum, significantly increasing the overall throughput to millions of transactions per second. Moving on, let's get into the technical aspects of Polygon's architecture, which operates on a 4-layer system. the Ethereum layer, the security layer, the Polygon networks layer, and the execution layer. The Ethereum layer consists of various Ethereum-based smart contracts. These contracts are responsible for staking, transaction approval, and facilitating interactions between the Ethereum blockchain and the numerous Polygon chains. This layer enables Polygon to maintain connectivity with Ethereum by periodically checking in. Also, we have the security layer, which works with Ethereum to provide validator services. This layer enhances the security of the chains by adding a layer of protection. It's important to note that the security and Ethereum layers are optional components and unnecessary for Polygon's functionality. Layer 3 is the Polygon networks layer, encompassing the ecosystem of projects and blockchain networks developed on Polygon. Each project or blockchain within this layer has its community, reaching local consensus and producing blocks. Lastly, we have the execution layer known as Polygon's Ethereum Virtual Machine, EVM. This layer's primary role is to execute smart contracts on the Polygon blockchain. The compatibility with EVM, as mentioned earlier, ensures a smooth user experience for developers and programmers utilizing the Ethereum chain. Polygon tokenomics. Finally, let's discuss Polygon's tokenomics. The Polygon network has its native token called Matic, trading at around $2 with a market capitalization value of approximately $13 billion. The Matic tokens are distributed monthly and have a total supply of 10 billion tokens, of which nearly 6.8 billion are already in circulation. The remaining tokens are allocated for staking rewards and have a time-locked release schedule, which we will discuss further. Initially, the developers sold about 3.8% of the total Matic supply during their initial private launch in 2017. Later, they conducted an initial exchange offering, selling an additional 19% of the maximum supply. As for the other tokens, the development team holds 16% of the supply. Advisors possess 4%, staking rewards account for approximately 12%, and the ecosystem holds 23%. The Polygon Foundation received around 22% of the tokens. Currently, as Matic tokens are generated to reward stakes, the token is technically inflationary. However, Matic has a limited supply, and the team plans to implement its version of EIP 1559. This means that base transaction fees will be effectively burned, making Matic a deflationary token in the future. Suppose you're wondering how stakes will be rewarded once the funds run out. In that case, the Polygon team hopes that the additional transaction fees that users voluntarily include to prioritize their transactions above the base fee will serve as sufficient incentives to keep staking validators engaged in the network. Well, that sums it up for today's video. Share your thoughts in the comments section, and if you have any questions on this topic, feel free to ask. Don't forget to subscribe to our channel and turn on the notification bell to keep seeing videos like this. See you in the next one.